Thank you so much, Charmaine. Almost a year ago, physics professor Donna Strickland awoke to some life-changing news. She and her colleague Gérard Mourou were the recipients of the Nobel Prize in Physics 2018 for developing chirped pulse amplification. They published this Nobel-winning research in 1985 when Strickland was a PhD student at the University of Rochester. Together, Strickland and Mourou paved the way toward the most intense laser pulses ever created. The research has several applications today in industry and medicine, including the cutting of a patient's cornea in laser eye surgery and the machining of small glass parts for use in cell phones. Since the time of that discovery, Dawn has been a research associate at the National Research Council Canada, a physicist at Lawrence Livermore National Laboratory, and a member of the technical staff at Princeton University. In 1997, she joined the University of Waterloo. Today, in addition to being a Nobel laureate, Donna Strickland is a professor in the Department of Physics and Astronomy, where her ultra-fast laser group develops high-intensity laser systems for nonlinear optics investigations. Donna spoke at the summit, which was hosted at the High Commission of Canada to the United Kingdom this past February. She joins us to kick off today's summit. She'll speak with me about how an investment in curiosity and research today will pay big dividends in our future. We'll have a chat, and then we're going to take a couple of questions from you. So while we talk, get those questions percolating. After all, how often do you get to chat with a Nobel laureate? Please join me in welcoming Donna Strickland to the Waterloo Innovation Summit. Donna? Welcome. I'm very excited to talk to you. So chirp pulse amplification has applications in health technology. So can you tell me a bit more about that?
Well, I guess the first one was the laser eye surgery. And it came from an accident, and I had nothing to do with this. Not I'm going to say it was an accident. It was in Gérard Mourou's group when he had moved to Michigan, and a student actually got the laser in the eye, which we were all worried about in our labs. And he was taken to the hospital right away, of course. And it was a young intern working there, an ophthalmologist. And he asked, what kind of laser made this damage? Mm-hmm. And they're all going, why does that matter? Can't you, let's worry about my eye. And he said, well, because the damage is so perfect. And it was a perfect circle. When you get other types of lasers in your eye, it will tear the retina. And it's the heat that starts to hurt the retina. And this one will just damage this perfect tiny round spot. So luckily he can see again because the brain will take over from a damaged retinal spot. And so it was the two of them that decided, let's start working together because this type of laser damages just where the laser focus is, and that maybe can be useful. So really, it was from damage in a retina that got to the point of where they realized they could actually cut the cornea. But that took quite a few years.
So the initiating factor was something of an accident in a way. Yeah.
Yes.
So what does that tell us about the way innovation happens and the way research happens more broadly?
I think science and innovation happens in all kinds of different ways. I've been asked this question a lot. My PhD was supposed to be about sort of a pure research idea of how light and matter interacts, but to do it in a way that nobody else had done it before, which meant at higher intensity, I needed a new tool, right? And so that's what sort of drove why we built the CPA laser, but we were trying to do pure science. And actually what we thought we were going to look at is not what we saw when the intensity got high. And so I think there's always this role about, sometimes it can be because you are trying to solve a problem, and sometimes it's serendipity and things just happen. Which is why I always say you have to let people just get out there and explore because you don't know where it's going to lead. Mm-hmm.
It makes you wonder about the potential for cross-pollination between people in different disciplines and the opportunities. I mean, if you think about that chance opportunity in the hospital and the different insight that somebody from another field had.
Exactly. The more we can interact, the better we are. Yes.
Yeah. So are there other applications for health technology from your research?
Well, okay, so that continues. I mean, the ophthalmologist will always be the first to use light because they're trained in the study of light already, since that's how we see. But as I understand it, this is now, for those of us that are older and have cataracts, we now actually destroy like when you have to take the lens out, for a few that are probably over 60 and having this done, we now destroy the original lens with our laser. and then can easily pull it out and replace it with a new one. That's one thing. I think going forward, most of the really big lasers are being built now in Europe and Asia. North America sort of let it go a little bit. And I said, why is Germany putting so much money behind this? And they said, well, we hope to accelerate charged particles better than we can do in hospitals right now. So right now they have linear accelerators in hospitals. Can we use our high-intensity laser, which will accelerate particles over a much smaller space than a linear accelerator? There's still a lot of technological advances to be made to do this, but if we can do it, it'll be a much smaller system in a hospital. The protons will get to higher energies and they can go deeper in. So there are some brain cancers right now that can't be reached. Can we do it? So that's one of the advances people are thinking about for health.
Yeah, can you expand on that a little bit? I mean, just to build on that, I understand that it's about reaching deep tissue tumors like those in the brain that are currently inoperable. So how would that happen?
Well, you can go in further. The more energy it is, partly, right? And so you have to get it up to the higher energies, and hospital scale accelerators can't do that right now because there's a limit to size and cost and everything else. I will say that to some extent, though, not to be negative here, but the scientists are just trying to really figure out, can we accelerate particles? Can we even beat CERN? CERN is the biggest particle accelerator in the world right now. It's 27 kilometers. They're going to go out 10 times that, so that's a huge amount of tunnel that would have to be built. Can we do better than that with the lasers, right? On the other hand, that's a big, expensive thing. And the one thing that probably gets government funding easier is healthcare. So to some extent, I will tell you, we're coming at it from both sides. Yes, healthcare people want it, but the scientists also understand that healthcare sells to the politicians more than, can't we build a bigger particle accelerator?
Right. Bit of a Trojan horse there, yeah.
But also, I mean, to get to better than CERN is going to take a lot more technological development, and beating an accelerator in a hospital is also a much more achievable goal. So it's sort of a win-win all around. It should be a stepping stone for the big scientific achievement, but hopefully it also leads to higher energy protons on a very small scale that can fit in a hospital.
Right. So you've been traveling all over the place talking to people, especially since your Nobel win. Can you talk to me a little bit about the relationship between that pure basic science and innovation, for example, this kind of health tech innovation, and how those two parts work together?
Well, first of all, I think that we have to always understand that science is probably there decades ahead of when it's going to be used in something like healthcare. I mean, it was very fast for us to go from a laser to the eye surgery. That took 10 years. But of course, the laser was already a tool. Yeah. And you have to remember that the laser started with Einstein's equations in 1917, and yet a laser didn't exist until 1960. NMR was studied 30 years before it became, because you can't use nuclear magnetic resonance in a hospital because that sounds scary. We now call it magnetic resonance imaging in a hospital. But that took 30 years to go from a scientific lab where people were just wondering, you know, what is going on with these magnetic spins. And so there has to be time for science to keep going, because it's the body of knowledge that we have that we can use to always come up with new solutions. And so we always need to keep expanding that broad science base.
Yeah. So just to return to the deep tissue tumor question, what needs to happen before we get to that point? How far off are we?
Oh, I don't know. Because, you know, I did my work as a grad student there all 40 years ago, and it was a laser fusion lab, and laser fusion's always been 20. It was, when I was an undergrad, I did a project, it was 20 years away. When I was in grad school, it was 20 years away. They'll still tell you it's 20 years away. But I'm, you know, let's all still be a believer. So you never know. So the issue is that the laser fields now are enormous right at the focus. Okay. To get to an enormous intensity in our lasers, we have to focus very tight, which means that it doesn't stay focused very long. So over that very small focal region, we can accelerate electrons or protons much, you know, orders of magnitude more than you can in a linear accelerator. But we only have this much distance. So now the question is, can we either focus, you know, get more powerful lasers to focus longer? Can we team some lasers up? Can we do it in chunks? Can we combine them in a certain way that would help. These are the technological challenges that are at play. So the acceleration fields are there. The question is, can we put enough of them together in a coherent way? We also have to first start with a proton or electron that's almost at relativistic speed, so it stays with the light as well, because the light is always going to move at the speed of light. The charged particles have trouble keeping up.
So what keeps you motivated and excited about this research?
Well, okay, so I'm not actually trying to do the biggest research. I'm not trying to do that particular type of research, but I just love working in the lab. I actually got to work very briefly yesterday in my lab. Hopefully this afternoon I might even too. And I always like to try to have new lasers. I think personally optics research is so much fun because we actually get to see what we're doing. Right now I work with infrared lasers, so we don't get to see that. But quite often we're frequency doubling, and the one that I'm working on in my lab right now is this thing that goes in, infrared light goes in, and every color of the rainbow comes out. So to me, it's a gorgeous thing just to see. And we're just trying to make new frequencies to see if we can add them together to make ever shorter pulses. And so to me, it's just a fun thing to do.
I read one interview with you where you said it was fun. Is it really fun?
Yeah, to me, yes. I mean, a lot of people ask what inspires me. I don't know. I don't know that I'm somebody who looks to be inspired. I just look to have fun, so I don't know.
So we're kicking off this day all about health tech. Why is it important for Canada to be part of and to fund this kind of health tech research?
Well, obviously, we're all aging. I know that more than a lot. And so, obviously, we have to start worrying about that. I think also, just for our economy, we want to be one of the innovators. We don't want to be one of the people behind. Sometimes I get, we sometimes in Canada, I think, sit on our laurels that we do own 15% of the world's resources, and so we don't spend maybe as much on research as some other nations do. And I think the more we can, I think the faster the economy grows too. So I think it's a win-win if you can, whether it's the environment or health or what have you, if we can help get innovative solutions, it helps the economy and it helps the solution for whatever problem we're looking at.
Mm-hmm. I have to ask, what did it feel like to get that call about the
It's
Nobel?
surreal. There was no other, I did the work 35 years ago. No one's expecting to get a Nobel Prize for something you did 35 years ago. And it's the call at 5 in the morning, so you're woken up out of a sleep. So yes, but I remember hanging onto my husband's arm while we were waiting. We were put on hold, and I had to sit there for 15 minutes going, I think this is the Nobel Prize. I can't believe it. Because they did say it's an important call from Sweden, and it was the day that the physics ones announced, and I knew that. Right? So, and it was 5 in the morning, and I knew that the call came in at 5 in the morning if you're on Eastern Standard Time, or Eastern Standard Time.
Yeah, wow. So we want to turn to our audience and ask if people have questions as you've been thinking about. I know it's always being the first one. No one wants to be the first one. We have a question over here, and we have mic runners just moving around.
Hi. So one of the most common health tech sensors that are pretty commonly used now are the PPG sensors that come in your wearables, your Fitbits, and those are optical light-based sensors. Mm-hmm. Do you see any immediate future applications in your optics research for earlier detection using light or a PPG sensor for detecting diseases or any other conditions that people may have?
Well, I have to say that I don't have enough experience with sensors themselves. I did get to spend a week as much of the week as I could at a Lasers for Medicine summer school. And I think there's an awful lot of work going on using light and lasers for umpteen different things. The question is which one eventually works and pushes out, I don't know. But certainly from cancer detection to diabetes to you name it, we seem to be looking at the spectroscopy of it, how to get it with some kind of simple sensor. Can we just, the fact that you scattered light now and the way that we know how to remodel how light scatters through tissue, that we can no longer have to necessarily stick a fiber into the body, I think is pretty exciting too. But I can't answer more specific than that. I think there's a lot of people around the world working on it. So,
do we have more questions? There's a question here.
Can't see with the light.
Dr. Strickland, I wonder if you have any advice for private industry that wants to work with basic researchers in universities, any way that you've seen can stimulate that, can make it more productive?
Okay, well, I'm going to just go back to my favorite country, which is Korea, for this. And then, actually, I probably shouldn't say this. People are recording now. I shouldn't say these things. Anyway, when I was interviewed in Korea, I was asked, what do you think we should do to win a Nobel Prize? They're quite upset that they've invested a lot of money in science and research, or research and development, and have not won the Nobel Prize. And I said, well, I don't know, but when I come to Korea, I'm always so amazed. And I said, you know, my parents lived there in 91, and how they described Korea and what I see in Korea today is so totally different. And I said, you put a lot of money into science and research, and now, you know, we're on our Samsung phones and we have our LG appliances, we're driving our Hyundais. I said, that's got to be more important to Korea than the fact that you haven't won the Nobel Prize. They didn't quite agree with me. They want the Nobel Prize, but I think Canada maybe wants Nobel Prizes, but they also want a booming economy. And the thing that I really liked when I went to Korea, and I think Germany is another country that does this well, is that Seoul National University, if you go to Seoul National University, there will be the Samsung building, there will be the Hyundai building, there will be the LG building. And when you walk into, so I went into the Samsung building because a colleague works there, and he was working on something that was funded by both the government and Samsung. But it wasn't a project, you know, because I looked at it and I went, obviously this isn't going to be a product anytime soon. And they said, no, probably at least 10 years. And so I would love to see North America take these models where industry is willing to come in and invest in the long term, not, you know, a lot of our projects here are supposed to be the 6-month turnaround. And that's very, I don't know, it's not my thing. But I just think so much happens when, if you get the government, the academics, and the industry all to play together in sort of equal parts, I think a lot of things come out of that. So that's what I would like to see happen here, is that we have these institutes where all three players are at the table and they're having discussions of it. One of the other things that I really liked in Germany, I love the fact that all of the photonics companies get together with all of the car companies, and they more than once a year, to discuss how photonics can help the car companies. And it's not just one car company with one photonics company. They're all there on the table, and they're laying things out. I'm sure they're also keeping their secrets. But nevertheless, I think, and again, it's the government that helps get these people together. And I believe the academics are invited to the table as well at that point. So I think, again, more dialogue, but also long-term vision, and the fact that we all should be playing towards that long-term vision is what I'd like to see.
Do we have more questions?
And it's very hard to see with those lights.
Yeah, we have a question over here.
Right here.
Thank you. And I'm sure this question gets asked a lot anytime anyone famous for their research speaks. But what do you say to your students, or what would you say to people who are interested in going into research, and how do you inspire them to do that?
There's that word, inspire, again. Well, you know, I guess I keep wondering, you know, I think if you really want to do it, there shouldn't be roadblocks. But I also think it's something you should really want to do. So I guess this is sometimes why I have trouble with inspiration, because I think in the tough moments, you've got to keep yourself going. So I think that what got me going through the tough moments was the fact that I knew I really wanted to do it. That's not that I didn't walk away for a while and think about it and grumble, but then deep down I knew I wanted it. So that is usually what I say to people, to know what they really want. Now, I also have been told by my daughter that one of her friends heard me say that and then dropped out of grad school, so I feel really bad about that. Hopefully that's going to be the right decision for that individual. So I didn't inspire him, obviously. But yeah, I think for some reason you have to really want to do it, because that's what's going to keep anybody going. But I think the question is, how do you know what it is you really want to do? And I don't know how to answer that question. Mm-hmm. I've told a lot of people, I was only good at so little, I knew what I wanted to do. So it wasn't hard for me. So maybe that's also why, since I couldn't choose from being a sports hero or a scientist or an artist, I knew which one I belonged in. So I didn't have to think too hard about it. Sorry.
We have another question back here.
Hi. I heard a lot of, sorry, you probably can't
I
see me
see you
because of the
now.
lights. But I heard a lot of conversation about hospital and using and applying your technology in hospital. Do you have any comments about, is there any research? I come from the long-term care sector. I know there's a lot of investment hoping that people age well, not in the hospital and more in long-term care and at home. So I was wondering, is any part of your research looking at that sector and how it's applicable there?
Okay, yeah, none of my research is really in healthcare at all, so I'd have to be careful to answer that. I mean, there's a lot of optics work going on for the aged, right? My colleague is working on how to use light to look in your eye to see if there's Alzheimer's ahead of time, right? You don't have to necessarily look at the brain after they're gone. And so that's an optics thing that she's putting forward to help people in the later stages of life. So I think there are that. Whether there's something to help while at the long-term facility, I can't think of anything off the top of my head optics related for that. But there's so many different things, there probably is. But it's not my own research.
Do we have any more questions?
Because we're at 0.
Donna, thank you so much. It's been a pleasure and an honor to meet you.
Thank you very
Please
much.
thank
Thank you.
Donna. Thanks.
Thank you.
Thanks so much.